All right. Hello, everybody. Due to the numerous requests for me to record a version of the presentation I gave here at PyData Krakow in Krakow, I'm now recording it for you. So this talk is titled A Short History of Computing and Its Next Paradigm, Agent-centric Architectures. And let's get right started. So first of all, I'm sure many of you already know about Bitcoin. In the talk, I usually ask people, like the audience, how many people have heard of it. Actually, when I asked that question to the mostly programmer-populated room in Krakow here, it was very surprising to me that only about 5% had even heard of Bitcoin, let alone owned any. And so then I usually go into asking like when it was born and how it kind of came about. And then we can talk about the financial crisis of 2008, 2009, and the following years, where 2008, Bitcoin was described in the white paper that was released. And then in January of the following year, 2009, the actual software came out and was started being used by people who were interested in this kind of subject. And actually started to also gain an interest from people who were seeking refuge from the claiming of deposits, like in Cyprus, in Greece, even Venezuela also. Venezuelans started to take interest in this. And so you can see that Bitcoin and the subsequent blockchain revolution that people are talking about comes out of a sort of libertarian anarchist ethos that is in opposition to the centrally managed financial systems where bankers and Federal Reserve and central bankers have the power to manipulate the money supply in a way that is according to their interests and their incentives rather than the ones of the entire populace. And that's, I think it's a noble goal to kind of supply the market of citizens with more options and the ability to withdraw from that system. Unfortunately, blockchain-based cryptocurrencies, in my estimation, cannot sustain that vision, but we'll get into that in a second. So once you kind of understand that where Bitcoin comes from, we can take a look at how it works. So you have, of course, on the one hand, one person, and on the other one, another one. And when you do financial transactions in the normal financial system, you do it through an intermediary mostly. Even if you use cash, which is much more direct than, of course, a bank transfer, you're still using the notes that the Federal Reserve itself has put out, if you're in the US, and of course in the other central banks, if you're in Europe or other places. And so you're relying on a medium that is determined, generated, and controlled by institutions other than yourself or the group that you are part of. And so what Bitcoin tried to do is do away with the middlemen. So Bitcoin tries to kind of leapfrog that process and allow you to just download a software to your device, which acts as a kind of wallet, an account on the network, and then allows you to transact directly from your account to the account of another, just via that software, basically moving around ones and zeros, that value. Now, blockchain achieves that. Well, Bitcoin actually was the first application of a blockchain, of the central innovation, actually, it was the blockchain. And so how does the blockchain work? Well, the blockchain works basically like a title registry, where instead of the title registry being centrally managed by a specific institution, it is replicated across the entirety of the network and then is updated across all of the copies every few minutes, depending on how quick the miners, which are the people who solve specific mathematical problems to secure this network, generate. And so it's kind of the very rough, very simplified version of how blockchains work, but that's really basically how they work. And because the blockchain itself is actually an innovation in database management or database technology, it can be used for many other things than just financial use cases. So you have identity, you have law, logistics, medical records, Internet of Things, file storage, and many more than that. And so the financial use cases, while being the most prevalent at the moment and the most sexy, let's say, are not the only ones. Yeah, we'll just leave it at that for the moment. Now, I think that blockchain is actually part of a much larger trend, and of course, not alone in thinking this. It is not original insight generated from my mind, but there's the saying, software is eating the world. And this was authored or pronounced by Mark Andreessen in the Wall Street Journal some years ago, quite a few years ago actually now, which he today or up to this day uses as his investment thesis in Andreessen Horowitz, one of the most, if not the most successful venture capital firm in the world. And the thesis is basically just that software is a radically different kind of soft technology, how Venkatesh Rao frames it, who wrote about this phenomenon. A radically different soft technology like money and like writing. But unlike those two previous technologies, has some properties that make it prone to basically eat up the earlier soft technologies as well. So right now, software is eating money. It is eating or has already eaten mostly writing, and is spreading its influence through every industry we can imagine. And of course, if you have the kind of insight early enough, which these people did, you can structure your investment thesis around that, and that way make some money. And just recently, or I guess a year or two now ago, the same guy, Mark Andreessen, also said that the blockchain is the most important technology since the internet itself. And I kind of agree with the sentiment. It is a huge innovation in how to structure a network of participants in a way that it gains the ability to transact value independently from any specific organization or set of organizations. At least in the very beginning, this held true. This is not the case today anymore, simply because the architectural choices of choosing the mining mechanism drive the Pareto effects of capital compounding on itself that Marx also described, even much more than already in normal capitalism that this happens. So today we actually have in the Bitcoin network, I believe the 5 top mining pools or miners control 80% of the network power, something like that. And so collusion or making specific decisions or altering the network really can be made with a phone call, basically. And so kind of blockchain itself falls short of its own ideal in achieving the vision it sets itself out to achieve. The kind of Bitcoin itself, even the white paper was called Bitcoin, a peer-to-peer digital cash, I believe, something like that. And so really the ambition was to make a cash, something that you can actually transact in small amounts feasibly and with anybody, independent of who they are. That's not the case anymore today. Bitcoin is incredibly power and money hungry in the sense that transaction fees are spiking up. And now the kind of ambition has been downscaled to be a more digital gold kind of thing. And there's Bitcoin Cash, which is kind of trying to be the cash vision, kind of carry that vision forward into the future. But I would submit that even Bitcoin Cash and other subsequent innovations on blockchain technology are not enough to sustain that because of the architecture choice, which we'll get to in a second. But really, if you think about it, the blockchain is such a big deal today because the internet, when it was designed and started to grow, did not have a native value transfer protocol. So when Tim Berners-Lee designed the infamous World Wide Web with this proposal, Information Management, a proposal, It was designed to be a information sharing network. So the idea was not value transfer, but information sharing. And so it's quite understandable that through its growth, it never had that native layer that you would need to conduct commerce on it. I mean, people weren't even thinking so far into the future. They were just saying, hey, wouldn't it be cool if we could more easily conduct research, basically, and communicate? And so due to those architectural choices from the very beginning, the internet's kind of model of how individual computers relate to each other is based on the client-server model. So you have the personal computers that give you access to a network of servers that serve the information that you access as a client. And the servers maintain an absolute truth and have the people who have admin privileges on those servers have the ability to change that truth unilaterally. And you are, you're just a client in a sense. It's more like a relationship where one side controls the truth or controls the setting, the frame, the information that's on there, and the other one basically just reads from it. Of course, you have changes that you can make, but that's the basic model. Now, in recent years, AI has kind of taken off and big data has taken off, and it has taken off because of this specific model of how our computers are organized. So data is generated by the users of a specific application or program or site, but all of the data is stored centrally on these servers that the service providers control. And so they have today a wealth of data available to them that gives them the ability to make use of it. It's what's called data capitalism, I believe. The idea that, or the system where really strong and big organizations structure an entire experience for you that makes you able to, that is advantageous to you. Amazon, Google, all of these provide a valuable service, so you want to use them. But the flip side of that is that you generate data for them that they collect, which they then use to influence you or to gain revenue from selling that data to relevant parties, be it advertisers or other kinds of business models that make use of your personal data. And that's what we are seeing today. It's also part of the driver of this kind of polarization we're seeing in the political sphere, where people are having trouble relating across political divides simply because the algorithms that determine the experience of their experience on the platforms like Facebook, like Twitter, they're slanted in a way that they serve up information to you that either confirms your pre-existing biases or makes you outraged. So the idea there is really to make you spend as much time as possible and to have as predictable an emotional response to the content that you consume as possible, because those are kind of the two factors, the two drivers of revenue for these platforms, because they then are able to serve up advertisement to you that kind of pushes your buttons, and just also, of course, the more time you spend there, the more advertisement they're also able to show you. Now, deep learning is kind of the way that people are now using this wealth of data available to them to make ever more sophisticated models of the world. And when you do that with interesting subjects like this, you end up in curious places. So Facebook recently didn't announce, but was kind of found out to have been patenting tech to determine the social class of its users. And of course, that is a very controversial thing to do, but it's just a logical conclusion of the amount and type of data available to them and the incentive they have to make use of that as their business. as people say, if you're not buying anything, like you're the product. And so kind of the vision that then normal users develop from this kind of understanding of how AI works and how it might impact them in the future is kind of this overlord AI, the kind of singularity vision that some of these tech utopians in Silicon Valley and other places have, where it becomes ever faster at learning and ever more intelligent, kind of this compounding effect of intelligence, leading to a super intelligence that then kind of takes over, so to speak. Now, I think that this is a kind of boogeyman that we definitely should take seriously in understanding and kind of considering how a vision like this might come about. But I think it kind of it comes from a wrong understanding of intelligence and how intelligence works. From my understanding, the actual kind of go-fi model of intelligence as good old-fashioned AI, where artificial intelligence is kind of this disembodied process taking place in computers, is a like this model building AI is a wrong understanding of intelligence. I think it was in the 70s that Rodney Brooks, one of the AI researchers, actually proposed and showed how intelligence is an embodied process. It is something that is made up of individual modules that, when subsumed into a hierarchy and connected to each other through feedback, they become what's called a subsumption architecture kind of system, where individual modules do very simple tasks that sense the environment and may respond or may not respond, but then maybe other modules respond to that or modify the response of the simple module that sensed that environment. So it's understanding that intelligence is an embodied process. So the idea that AI, this kind of thing in the cloud, will take over, I think is the wrong understanding of it. But it's understandable why we have this idea, because we also think about, like, we always try to anthropomorphize these kind of things or to understand these kind of dangers in a way that makes sense to us. And so we basically apply the God idea to this problem. Now, I want to talk about kind of a different a different way to make intelligent processes in digital space possible that that isn't based on this client-server model and this wealth of data available to people who structure your experience. And that is a technology that is building on a agent-centric model of computation. And that's called Holochain, and you've heard me speak about this before. This is basically just the branding used to describe a specific sub-project of a much larger project called Scepter, where that larger project itself instantiates biologically inspired processes into digital space. Now, the reason I'm bringing this up is because if you think about how biology or how nature patterns its existence and the things that survive in it, then you don't see this kind of centralized model where there's a steering cell in your body, like the CEO cell, that steers all the other cells. But instead, it is really made up of kind of this radically decentralized and distributed intelligence architecture where individual parts do very specific things. They differentiate themselves from each other, but are still subsumed into a superordinate structure that works by all these different things, doing individual things that make sense for them and that are fulfilling their incentives, their needs, their requirements to survive. And so Holochain is kind of this, it starts from a different philosophical understanding of how computing can work, where instead of having this client-server model, you have an agent-centric model where computation happens on your own machine and you yourself generate the data. Data is always an assertion by a specific agent. It's not this kind of universally true statement about the world that can be modified by admin people, but instead is an assertion by an agent, and so can be seen differently from different perspectives from other agents, and has to be reconciled with other agents' perspectives to have some kind of shared social reality. And so if we read here how it's kind of designed, so holochain applications are held entirely by the people who use them. So there's no server that kind of controls the social reality, but instead you have the entirety of the DNA, like application DNA on your machine. The rules after which you are able to generate data, like if you imagine a Twitter clone, you're able to write posts on your own machine to your own chain. That's why it's called holochain. But then that data can be shared with others in that specific social space that you share with them. Also, there are no trusted third parties. I already talked about that. And so there's a direct communication and consent possible, because it's it's an unenclosable carrier. I really like that concept, that idea of a kind of substrate or medium that you cannot enclose. So if you think about how capitalism and kind of the Western ethos is fueled by the heroic individual, the heroic society, and then kind of evil nature, then you can see how this kind of extractive capitalism of cornering a resource, extracting value from it, and restricting access to it, today is replicated in the server-client model in digital space. But there's a different mode of being that also is viable and that works actually much more sustainably, which is that you have like a stewardship over a specific resource that takes into account all of the externalities, the kind of indirect negative consequences that result from these kind of extractive processes, and tries to minimize them or kind of string many different parts that do these kind of things together into an ecology where the flows throughout the entire system are regenerative and not just extractive. And so holochain makes those kind of patterns possible in social applications in digital space. Now, this is the kind of simplified architecture of holochain. So it's not like Ethereum where or other blockchain platforms where there's a specific platform on which all of the different applications and social networks take place. But instead, with holochain technology, it's not a platform, but a technology, you can build applications that build their own networks, their own spaces between individual computers. And so if you imagine, again, the Query example or Slack example, maybe, if you and I are in the Slack team, we were part of a company, then our Slack communication takes place exclusively between the computers that you and I and our other team members have. And so it bootstraps a network for that specific social space, for that specific application. Now, the parts here are actually quite probed or proven technology. You have, on the one side, the shared storage, which is in a DHT, is a distributed hash table. This is what makes torrents work. Torrents are basically, they take a file. If you want to download a file from another person's computer directly, then what you do is you look for the hash, which is a quasi-unique string of characters that is generated when you put a file through a specific algorithm. And that hash then is listed on these kind of hash tables. So it's just a table of these hashes. And so it says like Marvel X-Men movie, and then you click on that magnet link, and then it looks up that hash. And that hash then shows you which other computers have that file on their own devices, on their own hard drive. And so then that network, the direct network is bootstrapped, and you can download that file from them directly. That's how torrents work. Now, Holochain combines this technology, kind of gives it another feature, which is called validating. So it's a validating validating distributed hash table, meaning that you're only able to upload a hash to this distributed hash table if the way that this data is generated conforms to the rules of the application that you're participating in. So that means that if you're participating in a Twitter, holochain-based Twitter, and let's say the character limit is 140, and you exceed that character limit in your post, then the distributed hash table won't allow your generated post, your generated data, to be uploaded to the distributed hash table because it doesn't comply with the rules that require you to stay within that character limit. And then it has another property that's not mentioned here as well, which is that it's a sharded validating distributed hash table, meaning that in order to participate in a social space like a shared Twitter based on Holochain, you agree to carry some of the data of other people that are also part of that social space. So that's kind of paying your way into that social space. You agree to host some of those hashes, some of those files that other people generate on your device, and so do they for you. And so that's kind of how you guarantee redundancy, so that when your machine is offline, other people are still able to access your content, at least the content that is generated for a shared space, without you being online. So the other part then is the source hash chain, which is what you do on your own machine. So you generate your post in that Twitter application, let's say, and each entry is then added next to each other. It's appended to the next one or to the previous one. And so you keep your own source hash chain on your own device, and the entries that are that you post to shared social spaces. So, for example, in a channel in Slack, they get uploaded to the DHT, and they also get kept there by other people. And so then with that, you have kind of you also have encryption, or you have the ability to encrypt there as well, but they're signed by your private key, by your public key, meaning that it's provable that you made this specific sequence of entries, and that way you also guarantee the data integrity that is necessary to have any kind of value transfer or kind of keeping you accountable to your agreements or to your pronouncements. That is necessary if you want to replicate or kind of fulfill the blockchain innovation, what blockchain brought to the table, which is that incontrovertibility of the data in another way. And the last part is the application code, which specifies the rules by which you can generate data and how the application itself functions, the data structure, the valid values, etc. So here's another example or another more sexy graphic of that. DHT down there, you've got the application code and the DNA, you've got your private source chain, and then you've got the way that those entries are communicated to others via the gossip protocol. And so Holochain is really the first that I've seen, the first in a I think generation of technologies that carry forward some of the vision, some of the ideas that were behind Bitcoin and the blockchain revolution, but actually in a scalable way. So it's already at a place where Holochain technology can sustain millions of transactions or interactions. It doesn't have to be of transactional character per second, simply because the interactions take place on the lowest level. They don't have to be carried by everybody, but just between your machine, my machine, and then if it's part of a larger social space, then it'll get replicated to the other spaces over time. And so this kind of architecture has some specific properties that make it different and perhaps difficult for current generations of programmers to work with. And so I'll just list them here. We have the sharded DHT, which is a non-searchable space, and I'll get into what problem that presents to programs and how they might go about solving it. So you have the sharded DHT, which is a non-searchable space. You have permissioned access to data because people control their own data. It's generated on their own device locally and only then shared to larger social spaces. You have data being an assertion by an agent. So it's always like it's a measure that you generate rather than something that is assumed to be universal across all perspectives. There is no universal perspective on the entire network, but there's perspectives, individual perspectives of all the participants on the data that they are able to see. There's no universal time sequence because the kind of the data proliferation takes a bit of time, even though it's very fast. And so you can't think about it the same way as you could with a server-based model where where there's a very clear sequence of events that take place that are all able to be put into a universal time sequence. There's a different relationship to the user simply because you're not maintaining ultimate reality for them, but rather they have their own reality that they generate, and then if you want access to it, you have to think about it differently. You have to kind of negotiate, really. And then there's also pluggable UI for all applications. So every application has UI hooks, but people can swap out UIs. So the experience across individual users is different. And so here's kind of the challenges for programmers and how they might solve them. So for the non-searchable DHT, you need a separate indexing mechanism of data that if you want to do some kind of sophisticated or very fast analysis or evaluation of it. If you want to use that data, you need to give the users a strong incentive to share that data, and that can of course be monetary or kind of public good or anything like that, but it's kind of goes to that they're in a different relation to the user. They are sovereign, you're a service provider. You're really approaching them kind of from a requesting attitude, stance. And because data is an assertion by an agent, there are no universal admin functions to change data after the fact and to kind of mess with what individuals have generated, have done. So again, it requires a different kind of stance towards the whole thing. And when there's no universal time sequence, you have to program for and take into account asynchronous communication taking place and conflicting views on the same events existing, and how to resolve those. And then you also have to program kind of UI agnostic, meaning that you might provide a specific UI, but other people might create new UIs for that application. And so you still want those to be intelligible, even if they don't use your own UI. So that's basically it. If you have an interest into these kind of subjects, you want to ask me questions, please go ahead. I really recommend reading breakingsmart.com by Venkatesh Rao. That's also where I got the AI graphic from, which is by Grace Witherell, whose graphic work I also recommend highly. Breaking Smart is about the way that computing proceeded throughout the 20th century up until today, and how first hardware led the development and software, and how today this kind of normal way of software development through GitHub and through like small teams, etc., kind of came into existence. Very, very well worth reading. If you're interested in the technology I presented to you, do go to holochain.org. And if you're interested in really driving this forward as well, you can go to holo.host, where they're doing a crowdfunding and an ICO soon. And you can find information that I've generated and am a part of at my website at moritzbieling.com, and email me at author@moritzbieling.com. So thanks for listening, and I'll talk to you in the next one.